Hello and welcome to today's webinar on using H2X to calculate heat loss. I'm just starting a couple of minutes late, just giving some people the chance to join as they get reminders in the calendar. But as a bit of an introduction, my name is Jonathan Mosdell. I am a mechanical engineer. I'm one of the co-founders at H2X. We recently released our heat loss tool, which is already being used by over 100 heating engineers. And the reason it's so popular is because it's been very easy to use, it is accurate, and it is visual as well. So this means that the software will get you to your heat loss results quickly, and you're not going to get bored along the way, which we know can happen when you're filling in line after line or number after number in a spreadsheet. So during this webinar, we intend to fully train you on how to use the software. It shouldn't take too long. And we will go through the settings that inform the calculations, how to draw the building. We will review the results. And at the end, we'll take a look at the report that you get as an export. And you can ask questions during the webinar, so please do. I'll answer any relevant heat loss ones as I go, assuming that I see them. And for any other questions, I will answer them at the end as well. So yeah, the aim of this webinar is really by the end of the 30-minute session, you'll have all the information that you need to log into H2X for yourself and easily undertake all of your heat loss calculations. So I think we have quite a lot of people here now, so I will get started. All right, so when you log into H2X, this is your home page. If you've just signed up, you will get put into a training workflow, which is useful to follow. But if you're following this webinar, I would recommend just clicking on the home button and coming to this home page, and then you can follow along as I do, which is probably easier. And then to start your project, you've got the big green button here, new project. You want to click on that and it will bring you to a bit of a project setup screen. So what you want to do here is just make sure you've got the correct flag ticked. So for example, if you are in the UK, you'll want this one selected. Choosing the US one would mean all of your units are in gallons and feet and inches and things like that. So yeah, just important to get that correct. And give the project a name. So I'll just go with webinar for this one. And when you're happy with everything, click next. Now, because H2X does a lot more than just heat loss or heating calculations, there are some fields relating to like domestic water, gas. They are all set to a default, and if you're not designing them, it does not matter at all. So just skip through it, don't worry. And even for the systems here, this again is if you're doing more detailed designs of, for example, cold water. If you were going to do your heating system design, I would recommend clicking on heating, and this is where you can select materials and velocities and things like that. But we are not going to be going into the details of like a heating system design today, so that's just more if you plan on going into that after your heat loss calcs. But yeah, today we're not going to be looking at it. And the last thing it's going to ask you is to choose from some manufacturers that we have built into the software. Again, they definitely don't relate to heat loss. They don't really relate to heating. So whatever your selections are won't impact what you're doing on your heating design. And once you've been through that process, you land on this homepage here, which is where you want to be. And this is where you now start doing the designing. So before we get into drawing the building and doing the calculations, it is very important to review the settings. So that's where we will start. So if you choose I'll click on the heat loss button here, and you can choose the heat load settings. It brings you to this page, and I'll just go through the important ones and explain what they do. So we've got the heat loss inputs here, especially the first three. So you want to set the external winter temperature because that's going to inform the delta T between your inside and the outside. So you can enter in any number here. And throughout the software, we have defaults built in from the MCS guidelines, and they use the CIBSE recommendations. So essentially we have the CIBSE recommendations built in as well. So you can change or enter that number. there will be a different input for the ground temperature, so it doesn't get as cold, so you won't lose as much heat through the ground. The thermal bridging coefficient is essentially just an extra percentage that you add on that's going to allow for heat transfer through things like metal studs. So just where the construction isn't perfect, it's just allowing for that heat transfer to happen. And it's also an opportunity, if you want to be conservative, you can change this and maybe you want to allow a little bit extra because maybe your measurements on site weren't perfect, or whatever the reason, you can change this number so we get 0.1. The heating degree days are for the energy calculation, which we'll cover in a webinar later this week, so I won't go into that for today. And it's probably worth noting, like at the same time as doing your heat loss calculations, it will do all your heat gain calculations too. Again, we're not going into that today, but it is useful to know that is part of the software. What is important is selecting the air changes per hour. So based on the MCS and CIBSE defaults, essentially the older the building, the more heat loss there will be because there's more air changes. So you're reheating that multiple times in the same hour. So if it's a really old building, it will have multiple air changes. The newer buildings, less so, but obviously it's very important to pick this correctly because it has a real impact on the heat loss of the building. And then the next three options are for choosing your defaults. So here you can choose from a range of materials for all of the different components of the design. You can choose a color as well, just to help you visualize it when you're drawing it. And you can set default dimensions too. So for the window height, for example, if you know all your windows are going to be 1 meter high, change that to 1 meter. And now when you draw them, they're going to use that number. And although we have quite a range of materials here, you can, at the top, you can add as many new materials as you want. So for example, if we wanted to create a new window, let's just call it new window, can choose it to be the window material, and then enter in the thermal conductivity, which, let's go with a big number of 5. As you add that, that will now appear in the drop-down menu here, so we can choose that if we want to. So you can go through and add as many as you want for all the different components. And then we do also have this second tab here, which is relevant to your designs. If you're just doing domestic, you probably never need to add a room. But if you're doing more commercial buildings, you might want to add some rooms that don't come as default based on what CIBSE recommend. So yeah, for example, if say you've got a hospital, it's a bit vague, but give it a name, whatever it is. You can then choose the temperature. So I'll just go really high and maybe there's 4 air changes per hour. You will now have this room to choose from and design with. And just like we saw the options before for the different building years, you can choose from these as well. So you can create a room that, if it was built quite a while ago, it will have different temperatures and air changes to if it was built today. And nothing really to change here, but there is a range of roofs that we will see, and they're really vaulted ceilings. So we'll see them later in the design, but just so you know, there's quite a lot to choose from, which is useful. And that is everything on the settings. So it doesn't look like we've got any questions so far. Yeah, again, feel free to ask them if anything's not clear as I go. I'll try to answer them at certain points, but if that all makes sense, I will move on now to doing the design. So doing the heat loss follows the same process, but there is a couple of different ways to do it. The first way is if you're doing a new build, so you've got floor plans, you can upload a PDF of that drawing. Once it appears on the screen, you can scale it so it's the right scale, and then you will follow the process that we will go through in this webinar, which is essentially just tracing over what is drawn. So yeah, just important to know you can do it that way. The way we're going to do it in the webinar is as if we've been to a building, we're doing a retrofit, so we've done a survey and we have all the dimensions wrote down. So just to reiterate, if we were doing it on top of a PDF, you're following the same process, you're just tracing over the design, whereas for this survey example we're doing, you're more looking at the dimensions and kind of building it yourself. Alright, so the place I start is by drawing all the rooms first. So we've got the drop down menu here. So again, a range of SIBSI MCS defaults. And as we can see at the end here, we do have the hospital that we just created. But let's just start with the lounge. So if we want to get started, just click anywhere to add your first point. And then as you pull away, we'll see now that we have the dimension tool, which is helping us. So say we've measured a room that is 7 meters long. Once you see 7 here, you can click again and then pull away. And then we can now add our next point. So let's say that was 4.5. The more you zoom in, the easier it is to get it exact. And if you're just doing a normal rectangular room, you do have these dashed lines which help you keep it on track. So as we intersect here at a 90-degree angle, the software will help us to find that. But if you want to keep going, obviously you can too. But yeah, we want to just go over a normal rectangle here. So what you can do is you can either double click, like double left click, or just do a single right click. That will then complete that room and it turns into a color. And you'll see in the middle, it's already calculated the heat loss. Now it's not exactly perfect yet because we probably need to add doors and windows and things, but just showing you how fast things do calculate and update as you're adding to it. You can drag walls around if you ever made an error. So if you want to change it, you can drag the corners, drag just one wall. And if maybe you've not done the full room, you can use the edit wall button. That will drop a point on and you can add as many of these as you want. And you can then use this to follow the perimeter of the room. But that's really drawing the room. We'll do a couple more examples in a second, but no matter the size of the building, you are just following that process. So if we click on this room now, we'll notice it has properties, and that goes for anything that is being drawn in the software. So it's going to be using all the defaults that we set, but it is an opportunity for you to override them. So if it's something a little bit unique about the room, then just come in here and change it. So for example, you can change the name. You can override the design temperatures inside and outside, and the ground. That's like the biggest governing factor in how much heat loss there is in the room. And then you can change some default like heights and materials. It will use the air changes from SIBSI, which you can override. But I just want to show you, like, if we do have a chimney in here, how much of a difference it makes. So the heat loss for the room is 1.44 kilowatts. If we had a chimney with a throat restrictor, it significantly increases because the amount of air that is now going out of the room. So it goes up to 2.9. And if it didn't have a throat restrictor, it goes up significantly again. So just highlighting how important it is for you to add things like chimneys, because it really impacts the design of the heating system. But yeah, all right, let's just add a couple more rooms now. So drop down this menu, we can do a kitchen off the side here. So you can just draw loads of different rooms and push them all together, but we do find it's better if you draw off what we already have. So if we want to start from this corner, if we hover over it, you can kind of see that blue crosshair, which just shows now that it's able to be connected, or you're connecting in the right place. So we can start from that point. And just like we did before, you can just click every time you want to put a corner into the room. And you will notice now as we get close to this, you get the quite solid blue dashed line, which is just indicating it will complete the room for you at this point. So if we right click or double left click again, it will complete that room. And yeah, there you go. You now have 2 rooms adjoining. And it is good to do it this way because it is now recognizing that this is an internal wall, which is the black one. So automatically it's been able to see that there's a room against this. That is now an internal wall. And I didn't point it out, but the heat loss number would have decreased because it was previously losing heat to -2 outside, whereas now it's the kitchen's at 18, so quite a bit warmer. And let's just do it one more time. So let's say now we just want to add a big dining room at the bottom. So we can choose this one. So we want to go here, and yeah, we'll just complete it like this. We now have the extra dining room, and that was 4.3 originally in the lounge, gone down to 4.2 because once again, it's not losing as much heat to the outside. So I won't do any more rooms now because it is very, very similar. You just keep following the same process. I will move on to the next parts, which are, well, I'll start with doors. So we've got two options for the doors. You've got your single door, or you've got the bifolding. So I'll start with the single. But essentially with this, it's like a brown rectangle that if you click now, you'll get a warning or just a message saying doors can only be on walls. And you know it's on a wall because when you hover over it, it will turn to an actual door symbol like this. And yeah, just click where you want it. So you can just go around now and we can just put a few doors in. And you can press F on the keyboard, so if you want to flip the direction, keep pressing F until you're happy with it. And yeah, it'll just be like that. And then if we want to add the bifolding doors, exactly the same process, but this time it looks a little bit different. And if we click on this one here, and I should just mention, like we saw for the room, this is similar for walls, windows, doors, absolutely everything. If you click on it, you can override materials or just specify the U value and temperatures. But in this case, if we want this to be, say, 5 meters long, we can make that change. And visually it looks correct, and I didn't point it out, but the heat loss would have gone up as well, because more heat will be lost through the door than the wall. Alright, so that's adding doors. Next is adding windows. So we'll move across to the window tab, and again there's two. So I won't add the Velux windows because that is for inserting onto a roof, but pretty easy to do. And in this example, we'll do normal windows. So if we select this one, hover over the wall, so similar to the doors, if you tried to put it here, we'd say windows can't be there. But we just click once to start the window, and if it's 1.5 meters, do the second click there, and then we can go around, add the next window here, for example. And again. So yeah, just like that. Now, if you've got a multi-level building, use the tools on the left here to add a level above. So if you add this above, you'll now get level 1, and you'll see the outline of the building below. So this will help you if you've got an upstairs and you want to put bedrooms and things, it'll help you to align it properly to below. But because it's just the same process, there's not much value in me showing you that, how that works. So I will just add the vaulted ceiling, which is called the roof. So here, if we choose this one, you can then, as we intersect with the corners of the room, you'll see the blue crosshairs again, and it's just a matter of intersecting with all of these and going round. So just give me 1 second. If you do have a flat roof, or just the insulation is on the top of the roof or your ceiling, there's no need to actually add this. It will just default to well, yeah, it'll default to finishing the heat loss where that is, and the insulation will be there. So this is only required if you do have a vaulted ceiling. So if we can just if we just look first of all, let's look at the lounge. We lose 4.26. Now as we change this roof to, let's put a gable roof in, we can see now the area and the volume below this has increased, so there's extra heat loss through walls, the actual roof itself, and then all the volume of air that's being changed. So that's gone up around 0.5 kilowatt just from making that change. And it's quite significant, but we do have a 2.5 meter height here, so if that was only around 1 meter, we update that. We'll see all the numbers update here. And then, yeah, the actual extra increase in heat loss will not be as significant. All right, That is everything on the drawing. So it looks like we have a question from Michael about what happens if you move an external wall that has internal walls connected. Yes, they will. So if we move this, for example, that internal wall will move with it, and so does the window. If you're making a really complicated change, because it's so fast to draw with, I would recommend deleting the room and starting again. But yeah, if you just moving certain walls, it's easy, and things connected will go with it as well. And yeah, if you want to, you can just move them separately, and it will line up the dots. So it will try to recognize as you pull one wall and you pull the next wall, it will try to line them up as well. All right, so yeah, that's everything on drawing. Like I said, if you're doing a huge high-rise tower, it's just the same process over and over again. If you're doing a small house, it's pretty similar to what we did today. So I will move on now. We've got about 7 minutes remaining, so we'll move on to, I won't go into the design, but just to let you know, the rooms will show up as red until you've added heat emitters that provide enough heat to them. So this will be another webinar that we'll do later in the week, but it will essentially cover like adding your equipment, putting the radiators in, and making sure that you provide enough heat to your house. Or if you are doing a retrofit from a gas boiler to a heat pump system, you can see if you actually can provide enough heat based on existing radiators and if the pipe sizes are large enough. So that will all be covered tomorrow and Thursday. But we're just focusing on the heat loss today. So as we come over to results, we now have this menu on the right hand side where there's a high range of results that you can turn on and off. So I won't go through them all because it's quite self-explanatory, but let's just pick on, say, the doors. And without turning the result filters on, if you hover over a component like this, you'll see all the information. So the areas, length and height, the U value, and then the actual loss as well. And if you want to actually see it, you can turn on the heat loss through the door, and we can go around and look at them. So just as an example, this door loses 53 watts. This one loses much less because it's not going to an extreme outside temperature. And this one loses significantly more because it's significantly bigger. And then the same for the windows as well. If we want to turn on the heat loss through the windows, we can see here this one's losing 53, and they're all probably similar. Yeah, 55 and 51. So yeah, slight differences there would just be because of size changes. And once you're happy with everything here, once again, you can go in and edit this. It's all updating instantly. But what we probably want to do now is come over to the exports. So there's a range of things to export, and some of them make a lot more sense when you've done the heating system design, because you can export like a bill of materials of all pipe sizes and things. You can do a nice PDF. But what really matters today is the heat loss report. So this comes in a Word document because it's impossible to match the format of everyone in the industry, how they want the results. So, sorry, I don't have Microsoft Office on here. But the reason we have it in Word is because people can then take the information or edit it in here to how they want. It's not like locked in a PDF or anything like that. Okay, so just give you a quick summary of this. It will have your company logo, it will fill in the project details, and it's essentially just a breakdown of all the different information that has been inputted into the design. The heat emitter summary and the noise calculation form won't be completed in this because that's more for the system design, which we'll cover in the later webinars. But to go through the heat loss results, really just gives you a summary here of external temperatures, the internal ones, the total heat loss of the system, and as MCS require, the worst performing rooms. Then for the room features, I won't go through them all one by one, but it's just giving you a summary here of like temperatures, changes per hour, and all the other parts that contribute to the calculation. It'll tell you what rooms are adjacent to the other ones. and then how much area of each component there is and what the thermal conductivity is being used. So it's really easy to spot a mistake here. If there's a number that looks wrong, maybe you've chosen the wrong material, really easy to go back into the software, make a change and re-export. And then finally, you just get a summary of all the heat loss that there is. So yeah, you can use all this information as you require, but it is highly accurate, and because it's so visual, it's very easy to see if there has been any problems. And coming to the end now, so just to finish this off, I will just say as some next steps for people. I suppose first of all, we have a YouTube playlist channel. So if you search for us on YouTube, come over to our playlist. We've got a whole range of videos, but for example, if you go on building heat loss, which is what we did today, or even heating designs, which is like the follow-on from what we've done today, there's just 1 minute videos. Some of them are a couple minutes long, which just take you through the steps from essentially uploading a PDF all the way through to drawing pipes, adding your equipment and viewing your results. So it all follows a similar process to what we've seen today. And other than that, we do have a 2-week free trial, so feel free to, on our homepage, h2xengineering.com, you can choose to try it for free. You get 2 weeks unlimited usage, and if you wanted instead, or in addition to that, you can book a demo, like a one-on-one time with myself or another member of the team to go through the any questions that you have about the software or any use cases that you might have. And that is everything I wanted to go through. We've got 1 minute left, so I suppose if there are any other questions, please feel free to ask them now. But if not, I suppose thank you everyone for your time, and yeah, feel free to email me after this, which my email is just jonathan@h2xengineering.com. And yeah, looking forward to helping you out on your next projects. Alright, doesn't look like there's any more questions, so I will, yeah, I'll end it here. But yeah, once again, just thank you, and yeah, hopefully speak to you soon.